A thin semicircular ring of radius r, now this is having a radius r basically, right, has a positive charge q uniformly distributed over it. Now the net electric field E at the center O is given by basically. So if I talk about charge per unit length, lambda will be equal to q by pi r, right? This will be the charge per unit length because the entire length is of pi into r. Now if I take any element at an angle theta, let us take the element to be of thickness d theta. So what will be the electric field at the center? It will be in this direction, dE rather, right? So if I talk about dE, what will be the electric field at due to this? dE will be equal to k into lambda into r d theta, right? R d theta divided by of r square, right? Because r d theta is the thickness and lambda is the charge per unit length, right? So this is dE. Now if I take another element at an angle theta from the other side, right, it will be having in this. Now dE will be the same, right? It will be the same. Now its component, if I divide this into two components, one along the I cap, this also along I cap, and the two along j cap, along minus j cap. So I cap and I cap will cancel out the components of dE and dE over this side. So that means the net will be along this side. It will be 2 dE sine theta basically, right? Because if this is theta, this will be theta. This will be theta because directly opposite angles. So this will be 90 minus theta, or I can write this component will be 2 dE sine theta. So if I calculate 2 dE sine theta, this will be the net electric field, right? So it will be along minus j cap direction. So if I now know that it will be along minus j cap, so I can easily eliminate option D and option A, right? So what will be this? It will be 2 into k into lambda upon r square into sine theta into r d theta. Now I have to integrate it. Now I have to integrate it from where? 0 to pi by 2. Why pi by 2? Because I have already included this angle, because I have made it twice, right? So I have to integrate it from this 0 to pi by 2 only, right? So this will be equal to 2 k lambda by r square. I can take common, and r also I can take an r, and r will cancel out. These are basic r, both the r's are same. So it will be sine theta into d theta, and you will integrate it from 0 to pi by 2, right? So what is the integration? It will be 2k lambda by r, and what is sine theta? It is minus cos theta, and you will integrate it from 0 to pi by 2, right? So this will come out to be q upon, if I put the value of lambda also, q upon 2 pi square epsilon naught into r square, right, into minus of j cap. It will be in the negative direction. That means option C is the correct answer. So this was a relatively good question with respect to the level of AIEEE. So overall I can say that, you know, the 2010 AIEEE paper was a relatively better paper as compared to the earlier ones that have been asked, right?